So in the second project which we had as a classical task which going to be performed into the mushroom classification. So let's try to understood about the classification task in this case study, and also we require to know about the different kind of the methods and techniques to understand. So let's get started, and we require as these kind of the steps to completing this process or the project. So problem statement is the first definition, what exactly which consisting of and how does that going to be looks like. And along with the data cleaning and also the pre-processing steps, what are the required steps needs to be performed and by using the data set we had. And also the exploratory data analysis, we can perform some of the use cases scenario based so that we will able to understand the insights from the raw data set. And along with some of the benchmark classical ML models, they're going to be performed. Those may be consisting of different kind of scenarios, maybe hyperparameter tuning technique or maybe the K4 cross validation techniques. So building on top of that machine learning model and also the evaluation, then testing and also the validation with corresponding to the mushroom. So I hope you already know about the mushrooms. There are so many different types of the mushrooms, but one such scenario which we had is very important problem for many people is edible and also the poisonous. So which are two important problems for the many people. The classification process can be done using the different mushrooms have the features. So what happened? We need to be classify which mushroom it is. So there are the data set consisting the UCI repository. If you just click on this link, you will able to find the data set corresponding to the mushroom classification task. So the UCI, those you all don't know about the UCI repository, which is the machine learning repository for all the different data sets, which may be worked with classification task and also the regression task, or maybe the time series data. So data you can download the data set from here, or else I will share the data sets with you in the description link so that you can download from that. So in this data, we had different kind of the mushrooms. I hope already you have seen mushroom is maybe looks like this. So we need to be classified which mushroom it is. So then we can post this problem into the machine learning, and they can showcase as a data set some of the information which we're going to be required. So the data set consisting of different kind of the samples. So there are 23 species of the guild mushrooms in the Agrinus and also the Lepidus family. So which we are some kind of the domain knowledge which is going to be required from the domain experts. But currently we can have the data sets from the user repository. They already had a made setup with corresponding to whatever the domain knowledge we had. So each species is identified the different, definitely edible and also the poisonous. So these kind of edibility and poisonous are very kind of, you can say, which is anonymous to the many people. So unknown, edible, and not recommended, that one also. So this kind of the classification we can combine with the poisonous one. And also the guide clearly states that there is no simple rule for determining the edibility for the mushroom. So there is no kind of the simple rule to determine the edible, but we can have the rule for the poisonous. We can combine it with the latter class so that we can use by using that poisonous clause at all. So there is a problem statement which we are going to be working with by using this kind of the data sets. So poisonous will be going to be take classified by using the edible also. Let's also perform some of the data cleaning steps and try to understand post this problem into the ML. So we have just imported bunch of the libraries so that we will able to reuse these libraries again and again. So I'm also importing the data sets which we had with different kind of the values. So so raw data sets which we had with corresponding the 12 to 12 different kind of the columns and also the more than 12 columns also. Let's pose this into somewhat more detailed way so that to get to know about the data sets. So you can see something called as the poisonous and also the edible, which consisting of P and also the E. Okay, so P means poisonous and E means edible. So we by using these kind of that independent features, we are able to identify this target column and also some other features which we require domain knowledge. Obviously, currently we don't have that much of domain knowledge. You can stay with some kind of that nature kind of stark surface below ring is nothing but whichever having, let's say in this diagram, this is a stark surface. Okay, So below ring, so this is a ring, and this will be having this kind of the circular nature. So this kind of the ring we usually called as star surface nature. So if you go and check out some kind of the domain nomenclature or domain terminology, you will able to find this kind of the columns and also the features, what exactly that means is, and also what exactly the value consisting of S for that and W for that, like that. So to know about some of the data set, the mushroom data set having how many rows and also the columns, just for understanding and just giving some information with this kind of the data set. So let's get started with this. So we have different kind of entries. So 8,100 records around. So which add having the different kind of the data types, which may be having the object level and also some of the other strings level, right? So let's consider we don't have any kind of the missing values. You can also see that. And let's go and detailedly discuss about some of the other characters or maybe involved and what exactly the feature engineering hacks you're going to be performed with using some of the raw data sets consisting of. So before going to that, you need to understand what exactly the feature is, right? So B for bell and C for conical and X for convex and F for flat and K for knob and S for sunnex. So depending on the cap shape, okay, this is a cap, okay, so this is a cap. So depending on the cap shape, it needs to be identified with corresponding to those kind of the symbols. B for bell, like this, and cap surface also. So F for farbus and G for goes and Y for scally and S for smooth. So cap color, cap surface, cap shape, and bush uses, and odor, and gill adjustment, and gill spacing, gill size. So depending on, you can see these kind of terminologies and try to understand the way whatever we're going to put it out. So you can read out this so that you will able to get some informative by using the features we are going to be applied to get which mushroom is it is. So then we can try on that pose into the different kind of the perspective to understand more in terms of the feature engineering we have. So some of the feature engines I'm just applying here so that you will able to get some idea and understood about those kind of the values to take some consideration. So I'm just displaying the described. So described is basically helpful to understood about some of the values we are going to be get are part of the each and every variable consisting of what distribution it is. And also we can also find the unique values the way which we are going to be get. So the unique values with corresponding to each and every columns as looks like this. So I'm just converting into the list so that we will going to be get as a list a number of the unique values in one list. So the class having PND, we already know about this is the target column, and the cap size, which we heard about these kind of the values, and along with the cap color and order, the gill attachment, and along with the population habitat. So these kind of observations is going to be very helpful. Just want to write in the simple English where we already know about that, right? So to understood about any other person's users, you want to be deal with this kind of the conclusions at a time. So there are strange values in the stack root and the column, such as these kind of in this kind of the strings. So you can see the stack root consisting of these kind of the strings, but this kind of the question mark, okay, this kind of the question mark may not be helpful at the time of you are doing some of the pre-processing steps or maybe the model building. So that we had to be representing some of the missing values would say discussed over in the some of the distribution functions. So valley type column having only the one value, which means the column does not affect the class of the mushrooms. Okay, so may if suppose you are going to be classified with your poisonous and also the edible, you have only the one column value. So the same for the all the observation, it's going to be removed from the data set. That may not be ideally with the situation in the data processing, right? So we can remove those kind of the unwanted columns and also unspecified column values. So let's have a look on the data observation with responding to the distributions. So I'm plotting the subplots with corresponding to different kind of the information to showcase in terms of the different plots. So let's have a look about these kind of the plots by using your count frequency of the each and every value. So have a look about these class. So which is not imbalanced data set, but it having slightly imbalance. So at the time, this will be okay. So whenever you find any kind of the balance or imbalance data set, it must be around this 80 to 9, 80 to 20% maybe. Or if you can find it out the 70 to 30%, that may be having some other hacks to follow with to balance. But now it's very okay for 44,000, and also the this one is 3,000, and that is just a 300 difference. That is the okay. But you can also try it with the other features. How does they looks like, right? So let's start with the cap shift first, and caps information first. So cap information having X as a very high valued when compared to the F and also the B. So you can see the F and B will be very highly correlated with cap surface and also the cap colors. Okay. So depending on the cap shape and also the surface, it needs to be identified the edible and also the poisonous. So at the time it needs to be deleted some of the unnecessary points, or maybe looks like that. So it has a very less when compared to that and for seal. So what about the information with the boost and also the other and the gill attachment and the gill spacing? So you can look out, this is slightly okayish, but you can see this might be having very huge difference when very normal difference, but you can see the huge difference between the count of them, right? F and T. And also you can see these all are very low when compared to the whatever we had as an in value and also the F values. So slightly we had the detachment with corresponding to this, and also the attachment is so 7,914, which is very huge when compared to this to 10 only, right? So this kind of the observation you can little write down with couple of the steps to predict these kind of the classes. So just for understanding, you can also get some more. You can also draw on some with subplots and also the correlation plot. Then you will able to easily get some kind of the understandable these kind of the information. So let's also look about what are the drawn as just going to be well put it into this one. So class variable we already seen, and some of the variable attachment. This is also we already seen. And the plot is made easier. Notice that the value type as mentioned earlier. Yeah, value type is very less, right? So value color, this is, yeah, value type is very less. So yeah, we can ignore this kind of the columns at the model building and also the pre-processing steps. So at the time it needs to be deleted, right? And also the start and also the start root missing is denoted as question mark. We already occupied with that. So question mark may not be helpful at the time of doing any kind of the visual analysis and also the model building, right? So this is very high valued, so we need to be computed with corresponding to whatever we are going to be performed with categorical values. So then we can approximately get 30% of the missing values. So I have to think about that. If I had a many high number of the missing values, we can try to go with some kind of the imputation mechanisms with majority vote, or we can also try to do with some of the calculation to perform as a mean or mean. Let's go with the flow. So what will happen if we're going to be find any kind of the direct relationship between the each and every variable? So we're just to perform up to the univariable analysis. Let's also perform the bivariate analysis. So let's look on to this kind of the plot, which basically tells about the count of the each and every class, which consisting of different kind of the features we are going to be applied. So by using the class variable P and E, right? So these kind of the class variables we are going to be showcased. You will able to see the different kind of the visualizations. So according to that, you can drag some of the conclusions easily, right? So whichever having the order as a P. Okay, so order as a P and a class. This one, what is this? So this order, sorry. So this is the P and this is the R. This is sorry. This is the F. We will conclude as a P class. So like that, and also you can see F and also this having the N. You can conclude it as a P class. You can see this is very high when compared to this. This is very low when compared to this. Similarly, this one, this one, this one, this one, right? So you can conclude easily if else conditions to observe with these kind of the values, right, at the time. So for that we required this kind of the observation to write it down in the algorithm so that it will able to understandable and also the give some kind of the good intuition behind this kind of the probability of the values. Yeah, some of the drawbacks from some of the observations from these groups have their two different values, true and also the false, and the probability of these mushrooms is edible going to be increases if the Bruch's value is going to be T. So if suppose this is going to be somehow mushroom classification, okay, at the time we require to get the Bruch's values as a 2, T or false, okay. True or false maybe basically tells about the probability of the mushroom, the edible going to be increased or not. Similarly, the ordinal value. Similarly, the order variable having the strong relationship with the target variable. So what happened since it has the most most of the values are going to be related to the only one class. So for example, P, F, C, Y, S, M, right? So these kind of the values are going to be seen in the poisonous dashboard. And B is a buff, right? So this buff is consisting of only grid color. This always be classified as a poisonous. So that's how we require to delete some of these things so that it needs to may not be having this much of bias towards only one class. So sports print color also will be important variable in our model. So as per the ordinal value. So let's also look about the visualizing the things for the sports print color so that we will able to understand about what exactly it does. Okay. So let's see. So whoever having the print color, so you know right, the print color is nothing but what exactly the color consisting of on this. So let's see, in this case we're going to be get the color as a black, in the green, chocolate color, and white color, or the brown color. So depending on these kind of the colors, it's going to be identified with corresponding to the sport print color as a poisonous and also the edible. So in the next video, we're going to be see as the data preprocessing and also the model building.